MacMaths, let's do some maths today. Statistics. So if you've forgotten what cumulative frequency is from GCSE, then this is a lesson for you. Okay, so just going to quickly go through it, what it is, how to plot the diagrams, a reminder for that, and then we'll just look at a couple of questions from exercise 3C that I'll do with you. Okay, so we'll come to those questions in a second. Cumulative frequency. Actually, I'll tell you what I realised cumulative frequency was when I was teaching myself statistics. It is a graphical representation of interpolation. So that's exactly what it is. The way we do interpolation to find out positions, well, we just read them off the graph, so it's just the graphical version of that. Okay, so I've made something up. This could be the mass of anything. I've just done a little table just to show you how that works and why it's the same as interpolation. Okay, so here we go. So this is the mass of something, and you can, if we add up the frequency, 6 of these items, let's just make something up here now. Let's say the mass is in grams and these are apples, the weights of some apples. Okay, so 6 of the apples weigh between 0 and 10 grams, tiny little apples. 12 between 10 and 20 grams, and so on. If we add up our frequency column, 22, 24, there's 24 apples altogether. Okay, but what we do is if we wanted to find the median and the quartiles and other percentile ranges, we can plot a cumulative frequency diagram. Now, note I'm saying the word diagram now because we've got a couple of opportunities here. I'll talk about those in a second. So first of all, we need a cumulative frequency column, and cumulative frequency means you add it up as you go along. That's what cumulative is. So far we've only got 6, but in this here 10 to 20 now, well, it's all of the apples from 0 to 20, so it's this 12 added on, so 18, 22 and 24. Okay, so we've added those up as we go along, and we're going to plot the cumulative frequency. Now this is where it works out as interpolation. Okay, what you must remember, what is key to cumulative frequency, is you plot at the end of the group. It's the only thing where you plot something at the end of the group, and you plot the cumulative frequency at the end of the particular group. Now this group starts, as it happens, starts from 0, so this cumulative frequency curve, or diagram, sorry, starts from 0. So that would always be the case, not from 0, but from whatever that is, that's where you start. We're going to look at some that don't start from 0 in a minute. So the first one is 6, so we plot that at the end of the group. The cumulative frequency we plot at the end of the group, we must remember that. So 6, and I've just done it. Now, why it works out as interpolation, because if we were to join this up with a straight line now, okay, then what that straight line does is those 6, because that's up to 6, that means that there, the 6th one, the 6th apple weighs 10 grams. The 5th apple, we can actually read it off. And that straight line divides 4, 3, 2, 1. It divides this up like interpolation, and it gives a weight for every apple in that group. And because it's a straight line, it assumes that all of the apples within this group, these 6 apples, are evenly spread between 0 and 10 grams. Okay, and that's what interpolation does, doesn't it? That's the assumption that we make with interpolation. Now, if I continue to join these points up with straight lines, so 18 at 20, so 20 up to 18, so I'm just to here, 22 at 30, so at 30, 22, and 24 at 40, so at 40, 24 is there. Okay, so if I join these up with straight lines, I've got what we would call a cumulative frequency polygon because a polygon has straight lines, and I think that is, you know, the best way of doing it, but actually the convention is not that. The convention is to get a nice smooth curve. Okay, and that statisticians think that gives you a better representation of how the data in your estimate would be spread out. Okay, well, fair enough. Okay, in other words, more towards the middle, and you typically get this S curve All right. And now if you wanted to work out the median, well, there's 24 bits of data. You look at your cumulative frequency, and you would simply, if you remember, the median would be the 12th. Okay, so you go across from the 12th and you read down, and that point here, okay, you know, about 13 grams. This would be the weight in grams. Okay, the mass in grams. Whoops, mass in grams. And that would be your Q2. If you wanted to work out Q1, the lower quartile, so your 24 divided by 4, which is 6, you read across from 6 and down. Okay, and it's actually 10 grams, isn't it? That's Q1, and 6 of these are 18, so across from 18, and that's sort of Q3. Okay, if you do it on a piece of graph paper, once you've done Q1, Q2, and Q3, and you've got the scale there underneath this, you've got those. You can extend those lines down, and you've got your box plot almost drawn for you, haven't you, underneath it? Okay, that's what we used to do at GCSE, or you did if you were in my class. Okay, because we don't know the biggest or the smallest apple, we're going to estimate, and because the smallest group goes down to 0 and the biggest group goes up to 40, that's where you tend to put your whiskers in this case, unless of course you're talking about outliers and there's a formula to work out the outliers. Okay, so that's what cumulative frequency is. They may sometimes say estimate how many apples are over, 35 grams. So you go 35 grams is here, and you go up and you go across. Okay, and there's 25 there, and you go, oh, only one apple. Okay, because it comes across at the 24th apple, and there's only one apple bigger than 24, and so on. Okay. It might say, you might ask, how heavy are the last 20 apples? So you go, across, the top 10% of apples. So you go, well, that's 2.4 apples, and you work down, you go across, you go down, and you say, oh, they're all over 26 grams or whatever, and so on. So you can pull data off. Anyway, there we go. That's cumulative frequency. Let's do a couple of the questions. Okay, and here they are. Okay, we'll do this one first. So exercise 3C, I've done the first and the last question for you. There's only 4 questions in the exercise. The first one is this one. It's these pine cones, and it's got the masses of pine cones, and they're all between 1 and 2.2. Okay, so what I've done is I've started. I've done my mass along the bottom, and I've done it. Let's just stick this down here so it's not sliding around. Okay, you can sort of see that. Put a bit of masking tape on. Yeah. Okay, so I've done it so it starts at 1 and it goes up to 2.2. Okay, so let's put some of these points in. So the first thing that we need, of course, is the cumulative frequency. Okay, so let's add that cumulative frequency column, and we've got 7, 25, add 34 is 59, 60, 100, 115, and 115, add 5 is 120. And now you can see I've added those up. You can see why I went up to 120. Okay, I'm going to plot at the end of the group. So at 1.2 I'm going to plot 7. So each one of these on mine is 2, isn't it? 2, 4, 6, 7 is there. Put a little cross. 25 at 1.4, 1.4, 20, 30, 25 is there. You've got to be careful with this. 59 at 1.6, so 59 is there. 100 at 1.8, oops, 1.8, 100, nice easy one to label. 115, 100, 110, 115, and 120. Okay, at 5, and there we go. Starts from 1, so we're starting from 1, not 0 here, and you'd be doing this in pencil. As you can see, I'm a past master at this. Oh my word, look at that. I might take a picture of that later, send that one to me mum. Okay, that's fantastic. So what have we done? We've done that. We've drawn a cumulative frequency. Let's give a title, pine cones, 120 collected. Estimate the median mass. Okay, so let's get my ruler. The median, there's 120 pine cones, so the median is the 60th pine cone. Go across till we get the 60th, and then we go down from that, and it's just past that. Okay, and there it is. Okay, so 1.6. Oh, it's about 1.605 actually. So I'm just going to go. You know what? I'm just going to go 1.6. I'm not even going to go 1.61. Find the interquartile range. So, and the 10th to 19th. So the interquartile range. I'm going to go blue with this one. No, this is black, I think it is. So the interquartile range is. They always tend to give you nice things that divide up nice, or they always used to at GCSE. So we want the 30th, okay, because a quarter of 120 is 30. That's there. And we want the 90th, which is there. Went just past that, didn't I? Overshot it. And down. Do take your time. Okay, and I used to put, I'm going to put Q3 on that, Q2, Q1, and of course we're going in that direction, aren't we, with those. And so the interquartile range, just reading off, the interquartile range is 1.67 minus, hang on, I'm doing this wrong here. So that would be 1.61. I've read the scale wrong, haven't I? Each one of those is 0.2, so 6, 1.7, 1.74. Read that wrong. That's 1.74 minus 1.42, 1.44, 1.45, 1.45. So the difference between 40, 50, 60, 70 is 2.9, no, 0.29. So on, just always check, because you're under exam conditions and you're nervous, 1.45, and double check you've read them off right, and always write it down at 0.29. So the interquartile range is 0.29 kilograms. That means the middle 50% of pine cones are all within, 0.29 kilograms of each other. We've got to do the 10th and the 90th percentile range as well. So this is 10% of 120, so that's 12. So there's 10, 12. So there's the 12th one across and sort of down. I'm cheating there, and that is P10. Okay, that's the 10th percentile. Remember, a capital P and the percentile that it is. Okay, so the P 90 minus P10, that's the percentile range, isn't it? Is, and we'll work that out in a second. We want 12 in from here, so that's 108, 102, 104, 106, 108 is there. Let's go across and down from that point. Now yours, these are estimates, and yours will be slightly different than mine. That's P90. And if they are slightly different to mine, that's because mine's more accurate than yours, because I'm better at it than you. Okay, and so that is going to be 1.7, 1.74. Hang on a minute, I read the wrong one. Oh my word. 1.8, 2, 4, 6, 8, 1.88 minus 1.2, 2468 1.28, and that is 0.6 between the so there's 80% of the pine cones are within 0.6 kilograms of each other. That's that. Take away that, the P90, take away the P10. And if you want, draw, well, it tells not if you want, it asks you should draw a box plot. I'm going to be a bit naughty here. Perhaps I should have done that up, so I could have. We've got the scaling here already, and all I'm going to do is, can you see? I'm going to go there, there, pigs. I don't want to do that. Q1, Q2, and Q3 is that one there. Pretend that one's not there. I didn't draw that one. Okay, and so there's your box plot, and it does say a box plot. Does it say a box and whisker plot? Draw a box plot. So it doesn't want the whiskers on. If it wanted the whiskers on, you go down to 1 and you go up to 2.2. Okay, but a box plot is not a box and whisker plot, it's just a box. So Q3, Q2 and Q1, the median, the upper quartile and the lower quartile. Without that, I'm covering my finger up with that one. And that's that one done. Okay, let's get rid of that. Made a suitable mess of that, didn't I? Okay. Alright, let's rub all of that out. And what I drew earlier. These are me cats for this one here. Okay. So we've got these cats, we've got female cats and male cats and female cats. The F is for frequency. So you're asked to draw cumulative frequency on both graphs. So we're going to do that first. So we need a cumulative frequency. 1, 13, 20 is 33, 40, 50, 60, 67, 70. The 70 male cats. Now I'm hoping there's going to be 70 female cats. 5, 22, 54, 66, 70, and it's still sort of 70, isn't it, there? And we had naught on. Yep, so the 70, they weighed 70 female cats and 70 male cats. I think these were of a certain breed, this data. Does it say what they were? Domestic short-hair cats. Okay, so just your normal cats. And you've got to plot them both on the same axis. So let's do the males first. So 2.5 to 3. So at 3, the end of the group, we're going to plot 1. 3.5, 13, 11, 12, 13, 4, 33, 31, 2, 3, 4.5, 60. Next one, 67 at 5. And then at 5.5, 70. Now the group starts from 2.5, so the 2.5 starts there, and you can see it sort of goes, whoop, and then it sort of turns, and then comes up here in this direction, and you get this nice sort of S-curve, and that's the males. Okay, let's do the females. I'll do the females in red. So at 3 we've got 5. At 3.5, 22. Oh dear, doors open. 5.4. Oh sorry, 54. 54 at 4. 54 at 4 there. 66 at the next one, at the next interval, the end of the next interval. 70 at 5, which is there, and also starts there. and then steep here, and then we've got this nice curved tenor, and that's it, and that's the females. Okay, which has the greater spread. Don't need the graph for that. You can see that the males, so we've done that. Which is the greatest spread? Which gender has the greatest spread? You can see that the males are between weights between 2.5. They've both got cats in that particular weight group, but the males go up to 5.5, the end of that particular group. So they're spread over 3 kilograms, whereas the females are only spread over 2.5 kilograms. So the males. Female is underweight if it's 3.2, and male is underweight if it's 3.8. Which gender has fewer? Does it say anything else? Draw both sets of data. So you don't have to do interquartile entry. That's good, because that would take us ages. So we're just going to finish off now. So a female is underweight if she's less than 3.2 kilograms. So let's go 3.2 kilograms there. And if we go up from 3.2 kilograms, to here and go across. Okay, so going up from 3.2 kilograms on the bottom scale to the females and going across. Okay, you can see that that comes across at the 10th female. Okay, so as an estimate, we can say that 10 females are less than 3.2 kilograms. 90 females, no, 60. Do you know what? I'm thinking of the last one where we had the pine cones. So 10 females are less than 10, and 60 females are more than 10. So there's 10 females underweight. The male, though, they've got to be under 3.8. So if we go to 3.8 and we go up to there, and that 3.8 on the males comes across at 21. Okay, so that means that 21 males are less than 3.8. So which gender has fewer underweight? The females. Only 10 of the females are underweight, but there's 21 of the males that are underweight, because there's 21 males that are under 3.8 kilograms. 21 of them, which, you know, of course means that I've got to do 49. Only 49 of the males are the correct weight, or, you know, are not underweight, not the correct weight, not underweight. Okay, but that's cumulative frequency. Try and practice getting these nice curves and reading off percentiles and so on. And there you go. And there we go.